Hello, this video is to give you some assistance in homework 2.4. First, I'm going to start off by helping you do number 16. Number 16 says determine whether the curve, this curve right here, has a tangent at the indicated point. And so the indicated point that they're asking for here is x equals 0. So what you have to do is you have to find the slope of the two pieces at x equals 0. So let's do the top piece first. Well, to do the top piece, we have to do this little thing. F of 0 plus h minus f of 0 all over h. That's the difference quotient. That is also the slope of the secant line connecting the point 0 and 0 plus h. So we're going to go ahead and do this. So negative of 0 plus h minus negative of 0 all over h. This simplifies to negative h over h, which is negative 1. So the top piece gives us a slope of negative 1. Now we have to do, so I'll write top piece. Okay. Well, the second piece, the bottom piece, is x squared minus x. So we have to do that same thing, but with the bottom piece. So let's see. We have 0 plus h squared minus 0 plus h. And so this right here is f of 0 plus h minus f of 0, which is f0 squared minus 0 all over h. Now we're going to simplify this, and we get h squared minus h all over h, which reduces to h minus 1. Well, we're going to make h approach 0 like we've always done when we find the slope of the tangent line, and we have negative 1. So notice that this and this are the same. So that means that these two pieces connect. Well, we should check if they connect. And they do if you plug 0 into the top piece right over here, and then you plug 0 in the bottom piece right there, they both give you 0. So they connect, but not only do they connect at a slope of negative 1, meaning that they connect smoothly, not sharply, and also they connect at a point that has a slope of negative 1. Therefore, this curve, f of x right here, has a tangent at x equals 0, and that tangent has a slope of negative 1. Next, we have number 20. Here we have y equals 2 over x, and the directions say to find the slope of the curve at x equals a. So for the first time, we are not given a specific x value, but rather a generic x value. And so we do the same thing. Instead of a specific number right there, we have a instead. So we put a in that spot, all over h. And so now let's plug it in. 2 over a plus h minus 2 over a all over h. So what we have to do now is to combine the numerator into one single fraction. So a little bit of common denominators, and skipping a couple steps, we have 2a minus 2 times a plus h all over a times a plus h all over h. Then we simplify a little bit more, and we have negative 2h over a times a plus h times h. And then we cancel, and we have negative 2 over a times a plus h. What do we cancel? We cancel this h and that h. Okay? So now we are able to plug in 0 in for h, because we want h to approach 0 in order for us to get the actual slope. So we have negative 2 over a times a plus 0, which is negative 2 over a squared. What does this expression give us? This expression right here gives us the slope of the tangent line to this curve at x equals a. So by making a any value we want, we can find the slope of the tangent line at any x value. Part B of this problem says, describe what happens to the tangent at x equals a as a changes. So, what do you notice about negative 2 over a squared? Well, this number is always negative. What does that mean? It means that this graph, this original graph, y equals 2 over x, will always have tangent lines that have negative slopes. And notice that the larger the a value is, the more closer to 0, or the closer to 0 this whole expression becomes. This makes perfect sense because let's picture how this graph looks like. Well, everybody should know that y equals 2 over x looks like this. Right? And if I were to draw tangent lines at certain points, for example, let's have a tangent line right there. Well, notice that that tangent line has a negative slope. In fact, everywhere you draw a tangent line, it's going to have a negative slope. Now, the further out you go, like this one I'm drawing right now, notice that this is the largest a value yet. And notice that it corresponds or it gives a tangent line that is the less steep, the least steep. This confirms the idea that the larger your a value, the closer to 0 your slope is. Notice that the slope is still negative, but it's pretty flat. The line is pretty flat, and so the slope is pretty close to 0. The last problem that I'm going to give you some help on is number 34. It says, at what point is the tangent to f of x equals 3 minus 4x minus x squared horizontal? Okay, so the first thing we're going to do in this problem is we have to find the slope of the tangent line to this curve. And so like a similar problem, we are going to evaluate this difference quotient, f of a plus h minus f of a all over h. So we plug things in, 3 minus 4 times a plus h minus a plus h squared, and this is f of a plus h, minus, now we're going to do f of a, which is 3 minus 4a minus a squared, all over h. Now we have to simplify this. So this becomes 3 minus 4a minus 4h minus a squared minus 2ah minus h squared minus 3 plus 4a plus a squared, all over h. Now you can pause this video if you need to see for yourself what I did there. I definitely skipped some steps. Then we look at things that might be able to cancel. So 3 cancels with 3. Let's see what else. Minus a squared cancels with positive a squared. Negative 4a cancels with 4a. And I think that's it. Hi. So you have negative 4h minus 2ah minus h squared all over h. And that simplifies to negative 4 minus 2a minus h. Then we take the limit as h approaches 0 of that expression. And we have negative 4 minus 2a. This expression here gives us the slope of the tangent line. And if we want to know when that is going to be 0, we set it equal to 0 and we solve for a. Okay, that's it.